The Data Games project is developing software that builds on Tinkerplots and Fathom, tools for data analysis widely used in middle and secondary schools. Let's take a quick look at both of these before Data Games. Here in Fathom is a document containing data about the solar system's 8 planets. We can make a graph by dragging names of attributes to the axes. It looks like there's a relationship between these two attributes. We can have Fathom draw various functions until we find one that fits. We might try a quadratic, a cubic, even an exponential before settling on a power function with a variable exponent. We'll use a slider for the exponent. In the graph, we plot a function, year equals orbital radius, raised to the power k. Now we drag the slider until the curve goes through the points. Fathom is designed for use in grades 8 through 14. In Tinkerplots, designed for use in grades 4 through 8, students use gestures to create data visualizations. With data describing these cats, clicking on the eye color attribute in a data card allows us to separate the cats, stack them, change their icon to a circle, and fuse them into a bar chart. We can start over by messing up the plot. If we separate by numeric attributes, we can make a scatter plot. Let's use weight for the horizontal separation and body length for the vertical separation. Now that we've looked briefly at the existing software, let's take a look at the new work going on in the Data Games project. The Data Games software runs in a browser. It is a web application that requires no installation. We'll log in as guest. By default, Data Games launches one of a number of games. You can change the game using the menu. Let's play Lunar Lander. Games are independent components implemented in either Flash or JavaScript. In Lunar Lander, students pilot a spacecraft to land safely, quickly, and with fuel remaining. While playing a game, data is streaming into the surrounding data analysis environment. Watch this graph in this table. Using the keyboard to control the lander's descent, we can speed it up and slow it down. Observe the effect on the pattern of points in the graph. As in Fathom and Tinkerplots, we can make a slider, rename it, and use it in a formula to fit a curve to the points. With some analysis, a classroom activity helps you come up with a formula. We notice the line only fits points from the first part of the landing. That's because the acceleration wasn't constant. We can change the scale of the axes by dragging and even change the data values. If we make a second graph and plot speed instead of altitude, we can select points on one graph and see that they are dynamically selected on the other graph. A registered user of Data Games can save documents, returning later to continue. The Data Games work will result in a rich data analysis environment where students and teachers can explore game data to make and improve strategies for playing games.